Did you getting my voice? Please reply. Did you getting my voice?
Yes, sir.
Okay. Internet गेलेला होता. Okay. So we have to be study the thing related to the whatever the component used in case of your filtration, right? There are basically two components used for the purpose of filtration. One component is nothing but an inductor, other is nothing but a capacitor, right? So to study the inductor and capacitor, we have to see the whatever the function of inductor and capacitor. See, inductor have one of the important function that is that it only passes the DC signal and the block the AC signal. That is the function of your inductor, right? The function of capacitor is that it only passes the AC signal and the block the DC signal. That concept used for the purpose of filtration to passing the particular signal, right? So that we have seen the one of the important thing with respect to inductor. So inductive reactance XL is equal to 2 pi FL. This is the equation for the inductor, right? XL equal to 2 pi FL, right? So we know that 2 pi F indicate that frequency L indicate that inductance, right? So if frequency for the DC we have 0 frequency, right? So F is equal to 0 indicate that X 2 pi into 0, so indicate that your see in case of your so in case of your DC signal, see DC signal indicate the frequency is 0. So XL equal to 0. Phi is 0 because 2 pi into 0 indicate that 0. So inductive reactance equal to 0 for the DC signal. So it indicate that for the DC signal, it have 0 reactance, right? It have 0 reactance. But for the purpose of AC signal, what we have to do? Frequency, see, for the purpose of your AC signal, the frequency is not greater than frequency is greater than 0, right? So it indicates that 2 pi into something value, right? F indicate the something value. So whatever the XL value, that should be greater than 0, right? Greater than 0. So it indicates that for the purpose of that's when see when we have to be seen that the device used such as the inductor, in that case the inductive reactance is more in case of your inductor, right? See here for the AC signal, what we have to do? Frequency, see, whatever the frequency coming across it is not equal to 0, indicate that more than that of 0. So that what happened? It indicate that whatever the value coming from the XL is equal to 2 pi FL. So product of it is greater than 0. So for the purpose of the AC signal, it gives the highest reactance. So indicate that inductor gives the inductor is not sorry. So that whatever the AC signal, that should not be passed over here in this case, right? So this is the thing with respect to the inductor, right? So inductor indicate that it is the device which should passes only the DC signal. So that's why for the DC it gives the 0 reactance, and that's why DC should be passes over it. For the AC signal, it gives the it has some of the frequency, so it gives the more reactance. So AC signal is not passes over the your inductor, right? That we have seen here across here. Then we seen another thing such as the device such as your capacitor, right? So whatever the thing coming with respect to capacitor, that we have seen. See, the reactance offered by the capacitor is given by one of the important formula for the capacitor, or the capacitor's reactance is X equal to 1 upon 2 pi FC, right? X equal to 1 upon 2 pi FC. See, this is the formula for the capacitive reactance, right? So for the DC signal, see, for the DC signal, we know that frequency equal to 0, right? For the DC signal, frequency equal to 0. So 0 indicate that 1 divided by 0. See, 1 divided by F indicate that 0. So all of the thing multiply by it. So 0, 1 by 0 indicate that infinity. So for the DC signal, capacitor gives the highest reactance. See, 1 by 0 indicate that infinity, right? So for the DC signal, capacitor give highest reactance, right? That's why capacitor block the DC signal. Now see, for the AC signal, F have some of the value, consider as a 5 value, consider as a 5, and this 2, we don't consider as a 5. So 5 into 2, 10, 1 divided by 10. So it have less value, less than 1 value. So what it indicates that capacitive reactors have very less value when the AC signal is applied across it. So that in case of your AC, so in case of AC, that signal is passes through it. Why it is passed? Because capacitor offers very low reactance for the AC signal. I may again tell you the things related to the capacitor. See why the capacitor passes the AC signal and block the DC signal. That's why I'm telling you. See, X equal to 1 upon 2 pi FC. That is the equation for the capacitive reactance, right? So we know that for the DC signal, see, for the DC signal, we know that frequency equal to 0. So here 2 into 0, it is a 0, right? 1 divided by 0 indicate that infinity, right? So capacitive reactance have infinity value when we have applied the DC signal, right? So that see, for the purpose of capacitor, we know that your equation is X equal to 1 upon 2 pi FC. For the DC signal, see, DC signal frequency equal to 0. So 2 pi into 0, 0, 1 by 0 indicate that infinity. So what it indicate that for the DC signal, capacitors give the highest reactance, right? So capacitor block the DC signal. So that's why capacitor block the DC signal. Why it is? Because capacitive reactance is infinity, right? For the AC signal, what we have seen that frequency indicate that consider as a 50 hertz frequency, right? So 1 divided by something value which is less than 1, right? 1 divided by something value indicate that X value less than 1, it indicate that less reactance, right? Less reactance indicate that there should be passing of the AC signal. For the purpose of ACC, if is not equal to 0 indicate that if whatever the value coming with respect to XC, for the purpose of XC, 1 upon 2 pi, it has some of the value. So it indicate that whatever the X output is coming, it is a Are you getting my voice? There are so many times interrupt is coming. See, for the purpose of AC, whatever the frequency coming across AC is a greater than 1. So that 2 pi into any value, consider as any value, indicate that 1 divided by more value. So it indicates that the value of the XC is coming is very less, right? So very less indicate that for the purpose of AC, XC value is very low. Very low indicate that capacitor offers very low reactance for the AC signal, right? So that's why AC signal is passes over the capacitor. So we know that two things with respect to inductor and capacitor is that inductor is the device which should passes only the DC signal, and the capacitor is the device which should passes only the AC signal, as we have seen through the same thing with respect to mathematics. हे लक्षात आलं का मॅथमॅटिकली कॅपॅसिटर काय एसी पास करता आणि इंडक्टर का डीसी पास करता, लक्षात येतंय का? प्लीज रिप्लाय द्या. बरेच इंटरप्ट आले, पण सांगा मला की कॅपॅसिटर का एसी पास करता आणि इंडक्टर का ब्लॉक करता. मॅथमॅटिकली तुम्हाला सांगितलंय त्याचं रिझन. दोन इक्वेशन आहेत. एक्सेलच्या इक्वेशन तुम्हाला कळलं की इंडक्टर मधून का आणि का फक्त डीसी पास होता, आणि या इक्वेशन एक्स इक्वल टू 1 अपॉन 2 पाय एफसी याच्यावरून कळलं की फक्त कॅपॅसिटर मधनं फक्त आणि फक्त एसी का पास होता आणि डीसी का काहीच ऐकू येत. हॅलो, आता येतोय आवाज? आवाज येतोय का?
ब्रेक होतोय सर.
नेटचा प्रॉब्लेम येतोय. आता येतोय, आता येतोय का आवाज? प्लीज रिप्लाय. आवाज येतोय का? आवाज येतोय का? अंकल की आवाज येतोय का?
सर आवाज ब्रेक होते.
नेटचा इश्यू. आता येतोय का? नीट आलंय जरा. आता येतोय आवाज? प्लीज रिप्लाय द्या. आवाज येतोय आता? ब्रेक होत नाही ना? प्लीज रिप्लाय द्या.
सर ब्रेक होते सर.
ओके. हॅलो, येतोय आता? रेंज तर फुल आलेले आहेत. येतोय आवाज आता? प्लीज रिप्लाय द्या. हॅलो हॅलो, आता आवाज येतोय का क्लिअर? आता आवाज येतोय का? रोहित जाधव आवाज येतोय का आता? रोहित जाधव, आता आवाज येतोय का व्यवस्थित? प्लीज टेल मी. आवाज येतोय का? आवाज येतोय का आता क्लिअर?
नो सर ब्रेक होते.
ओके. नेटचा इश्यू लागलाय. आता काहीच आवाज येत नाहीये? काहीच आवाज येत नाही का? काहीच आवाज येत नाही का? रिप्लाय द्या.
येतोय सर आता.
Okay. We have seen that two things, that is the function related to the inductor and capacitor. Now we have seen the one of the important type, that is capacitor type of filter. See, we know that whatever the function of the inductor and whatever the function of the capacitor, see, that's why the function of inductor is that it only passes the DC signal. The capacitor function is that it only passes the AC signal, right? The same thing which will be used for the purpose of your designing of the filter, right? That we have seen in here, right? So we have seen the one of the important term, that is capacitor type of the filter, right? So this type of filter, what we have to do, this is the diagram of the capacitor type of filter. See, this is the normal transformer, right? It have applied the input, that is 230 volt AC supply supplied. In case of secondary, we have to be considered as a 12 volt. This transformer is type of the center type. See, center type indicate that upper half and the lower half have exactly opposite voltage, right? So it indicates that 12 0 12, right? 12 12 0 12, that should be called as this type of the transformer, right? So see, for the purpose of your center type of configuration, we have the apply the same thing, that is, see, we have applied the AC voltage, that is 230 volt AC here, right? Accordingly, during first positive cycle, this part should be considered as a plus, this part should be considered as a minus. See, this is the C type of filter. Here we have applied the 230 volt AC. Did you getting my voice? Please reply.
Yes, sir.
Okay, 230 volt AC supply is applied across here. Here secondary should be generated the 12 volt. We have to be considered as the this transformer of the 12 that is a center type of the configuration. So whatever the voltage coming across your upper half, that is exactly opposite to that of your lower half. That will be the thing with respect to the center type of the transformer. So during this first positive cycle, this should be considered as a plus, this should be considered upper part of this should be considered as a minus. Here lower half is called as plus, again this should be considered as a minus configuration, so that during the first positive cycle plus voltage is coming across this type of a diode. So that's why this diode should be conducted. Why? See, the diode conductor reason behind it is that anode have applied the positive voltage, right? So that's why it is a conducted, right? So that positive half cycle is coming across here. We have to be tell the up to the same thing only here. So positive voltage is appear across before the capacitor, right? So this will be happen during the first positive half cycle. So during C plus minus plus minus. So minus is a voltage. See, at first time minus is voltage appear across D2, so it is not conducted. Only the diode D1 is conducted, so positive voltage is appear across the capacitor, right? So this will be happen during this positive cycle. See, during this positive cycle, diode D1 is turned on, so your positive cycle is coming across your load, right? I may explain how the particular. See, this is the waveform coming across your capacitor. See, this is the right spike. So I'm telling you how it should become, right? So this will be happen during the positive cycle, during the negative cycle. So during the negative cycle, so plus minus changes from minus plus minus plus voltage is coming, so that my reverse voltage is appear across your diode D1, so that why it is not conducted now. So now positive, see, minus plus minus plus. So it indicates that anode of the D2 have the positive voltage, so that diode D2 is conducted, so that same positive voltage is appear across your capacitor, right? So either your positive cycle or negative cycle. See, either your positive cycle or negative cycle, there should be positive cycle coming across your load. This will be the thing coming with respect to up to this point. This point indicate that up to this capacitor, right? We have not telling anything with respect to the capacitor. Right? Now see, I'm already told you whatever the function of capacitor. Tell me the function of capacitor. Capacitorचं function मी काय सांगितले तुम्हाला? Please tell me. अंकल की तुम्ही सांगा, what is the function of capacitor? बचुटे तुम्ही सांगा, what is the function of capacitor? Please reply. Anyone?
To pass the AC signal.
And the block the DC signal, right? That is the basic function of capacitor. But capacitor have different other function also, right? See, charging, discharging is also another function of your capacitor, right? So see, during this first, we have seen that during this first positive cycle, we have seen that plus minus voltages appear across your diode D1 and D2, right? So during this first positive cycle, positive voltages appear across your capacitor, right? We know that another function of capacitor is that when it have applied the positive voltage, it should be charged, right? Fully charged up to the fully level, so that during this first positive half cycle, it should be fully charged. See, during this positive half cycle, here it should be started over the charging, right? It is started over the charging up to this point, right? Started up to this point, higher peak point, right? After the charging of this point, what happened? It have voltage which is more, right? So that it is a fully charged, again it should be discharges, right? So it should be again discharges, right? Discharges up to the certain level at the point of C. C indicate that this point, right? This should be discharges up to this point. At that point, the whatever the voltage, that level should be low, right? Low. During that time, what happened? Another diode, see, another diode, D2, another diode D2 should be conducted, so that again capacitor have particular voltage should be provided, so that again this capacitor start charging, right? This again this capacitor charge starting charging up to this level, right? So during this level, whatever the capacitor that should be fully charged, after see after fully charged it again discharges, so that again it should be started discharging, right? It should be discharges up to the level of this C, right? Up to the level of this C. Again see, at that level whatever the diode D2 conducted, that should be going out of conduction, but again the diode D1, see, D1 D2 D1 D2, that cycle should be remain. Again diode D1 is conducted, so diode D1 conducted, so it again gives the positive voltage across your capacitor. So again your capacitor start charging, right? Capacitor charge start charging, so it should be charges up to the highest level as a F, right? So after of F, it is a fully charged. Again, it should be start discharging. So it should be discharges over here, right? Discharges over here. So again, this level, it should be fully discharged. So when it is fully discharged, what happen? During that point, another diode, that is now D1 is conducted. Now during second half cycle, D2 is conducted. Again, it should provide the voltage to the capacitor. So again capacitor start charging, right? So charging and discharging of capacitor should be charge over it, should be running over it, so that we got the voltage what should be such is not the pure, that is not a pulsating DC. It should some of the less pulsating. See, this is the voltage coming up to this level. Again this should be increasing, this should be going again this level. So whatever the voltage coming across your capacitor, that should have less AC component, right? This will be happen with respect to your capacitor. That's why C type filter causes whatever the AC component coming with respect to your device is reduced, but it is not fully reduced, because see, only capacitor is not does the function of the reducing the ripple. It have requirement of the many more things, that is CLC. It is the configuration which reduces the more ripple in a case of your circuit diagram, right? So that see what it does, see what we have to see. When we have to apply the AC supply, this AC supply is applied there during the first positive cycle. Now D1 is conducted. Now I'm telling you all the things with respect to this capacitor, right? So during this first positive cycle, now D1 is conducted, so that positive voltage is coming across this capacitor. Initially, see, initially capacitor have zero charge, right? Zero or less charges, so that it start charging. See, it start charging up to the level of this, right? B, A to the B level, right? So capacitor charges up to the A to B level during this period, right? During half period of this waveform, right? Half period of this waveform, right? Input waveform. But at that point, what happened? It should be fully charged. So we know that capacitor function, it should be charged and discharged. So that again, when it will be fully charged, again it should start discharging. So it should be discharging up to the pi, right? Up to the level of pi, right? So at the pi level, again diode D1 go into out of conduction. Why? Because reverse voltage is appear across it, so that diode D2 is conducted, so that diode D2 providing the voltage for the charging of the capacitor, right? So that for again this point, it should be start charging. It should be charges up to the level of this D, right? After all, D, it is a fully charged. So when capacitor fully charged, it again discharges over it, right? It should be discharges up to the level of E, right? So again E point, there should be again due to go into out of conduction. Again diode D1 is conducted. So due to D1 conduction, capacitor again charging, right? So capacitor again charging. So capacitor start charging again this point, right? After all, this should be charging up to the F point. Again at the F point, it should again discharges over here, right? This cycle should be repeated again and again. So capacitor type of filter, it reduces the sum of the noise only. See, in case of your filter, if we have to use the only capacitor as the one device, in that case we have reduces some of the ripples in case of your rectifier, but we doesn't give the purely ripple free voltage with respect to your output. This will be happen because of only capacitor device. gives the less number of the reduces the less number of ripple from your input, that is rectifier output, right? That's why we got the output such as here, as we have seen here, right? लक्षात आलंय का कॅपॅसिटर आणि कॅपॅसिटरचं फंक्शन काय? प्लीज टेल मी. आणि कॅपॅसिटरमुळे जी वेव्हफॉर्म येते ती वेव्हफॉर्म म्हणजे चार्जिंग आणि डिस्चार्जिंगची असते, लक्षात घ्या. चार्जिंग आणि डिस्चार्जिंग झाल्यामुळं त्याच्या अक्रॉस येणारी वेव्हफॉर्म असते, त्यामुळे त्याच्यातनं रिपल जे आहेत ते कमी झालेत, ऍक्च्युली 100% कमी झालेले नाहीयेत, राईट. पुढे आपण एल टाईप पाहणार आहोत, पण सी टाईप लक्षात आला की नाही किंवा काही कळलं नसेल तर मला रिप्लाय द्या. ओके, सांगा लवकर. बचोटे सांगा, लक्षात आलंय का? नसेल आलं तर काय आलं नाही ते सांगा, मी रिपीट करतो. प्लीज रिप्लाय द्या. रिप्लाय द्या बचुटे. लक्षात आलंय का तुमच्या? अगेन एकदा सांगू का?
Yes, sir.
दळे तुमच्या लक्षात आलंय का? धनश्री
Yes, sir.
दळे. ओके. See, we have seen the inductor type of filter. See, inductor type of filter indicate that it contains same as earlier configuration. Rectifier means fully rectifier is connected across here, right? So fully rectifier indicate that we have applied the positive and negative half cycle across it. So accordingly, particular DC voltage, DC indicate that pulsating DC voltage is coming across here. See the diagram, detailed diagram. This is the output. Detailed diagram is here. See. L type of filter, right? See, this is the diagram of the L type of filter. See, we have applied as a input is nothing but a 230 volt AC supply is applied across here. This should be applied to the positive. This should be applied to the primary of the transformer. Again, when we have applied the AC signal, there should be there should be connection between primary and secondary as a flux linkage. There should be considered as a 12 volt. It is plus minus, that is the voltage coming across this type of the transformer, because this type of transformer is called as central type, means here 12 type of transformer is called this type of transformer, right? So during the first positive cycle, diode D1 is conducted, so that positive voltage is appear across here. So during the second negative cycle, see what plus minus, this should be during first half cycle. So during next half cycle, whatever the voltage coming across, that is opposite, so it is nothing but a minus, plus, right? So already conducting diode D1 is not conducting now, so now diode D2 is conducted. So due to diode D2 conduction, same positive voltage is appear across here, right? Same positive voltage is appear across here. So due to that positive voltage, right? So this positive voltage is applied across your inductor, right? So whatever the rectifier output, so we know that rectifier output is nothing but it is the output which have the pulsating DC component. Pulsating DC indicate that it have AC as well as the DC component, right? So whatever the device connected here is an inductor. We know that the function of inductor, it passes the DC signal, right? So due to that DC signal, what happened? Due to that DC signal only passes. So if it contains some of the pulsating components, see some of the pulsating component, it should be removed, and the pure DC signal is coming across load, right? But I'm telling you, only L or only C component is used. Whatever the function of it, it doesn't do, because it is not a perfect devices, right? No one in the world is perfect, so it is not perfect. Indicate that not the pure DC is passed over here. It also some of the AC component, right? So this will be happen when we have to use the inductor, right? See the waveform. See one phase AC signal. This is the positive cycle. This is the negative cycle. This is the positive and this is the negative cycle. That is the AC signal applied across your input, right? So when we have like this type of the signal, whatever the output of your rectifier indicate that this output of this diode is this diode D1, diode D2, again diode D1 and D2 conducted, right? So that's why whatever the output coming across your diode and D2 in a positive as well as negative half cycle, it is a pulsating DC output is coming across here. That pulsating DC output is applied across your inductor, right? So when it is applied to the inductor, so what happens? Inductor, what it does, inductor, the property of inductor, again see, one of the important property of inductor is that it opposes to the change of current, right? So that when we are applying the voltage, this voltage to the inductor, it gives the opposite to the change of current. See, during first this voltage, see, initially it is a 0, that should be reduced again, then again it should be increased or decreased, right? Means in case of your inductor, what it does, it opposes to the change of current, so that it is the same as like as the earlier diagram. Means it has some of the noise, it also coming with respect to this type of the diagram. And unregulated, see, this is the regulated pulsating DC, but unregulated DC pulsating voltage is coming across your load. But due to the only use of the inductor, there is a not reducing the ripple, but it have some of the increasing the ripple, only use of the inductor. So that inductor and capacitor, these two components which mixed with each other, and then that used with mixed each other, it gives the less amount of ripple. We have tell you this configuration separately. Only reason behind it is why the particular component is used separately and what they have to be used in a common, right? Whatever the effect. So when we have to use the capacity, it have also some of the ripple is coming. When separately we have to use the inductor as in this configuration, it also have some of the ripple is coming with respect to this configuration. So what it indicate that I already told you, when inductor and capacitor used for the purpose of the ripple reducing, when it is used, it use the less amount of ripple. But see, when it should be used alone, it should be, म्हणजे इंडक्टर आणि कॅपॅसिटर तुम्ही जर एकटे यूज केले ना, तर त्याचा इफेक्ट काय होतो की त्याच्यामुळे रिपल कमी होण्यापेक्षा वाढतायत. लक्षात घ्या, जर त्याचं कॉम्बिनेशन जर यूज केलं, GLNC किंवा CLC जर यूज केलं, तर त्याच्यातनं लेस अमाऊंट ऑफ रिपल येतात. त्यामुळे कॉम्बिनेशन ऑफ CLC और ELC जास्त प्रेफर केलं जातं, जेणेकरून त्याच्यातनं लेस रिपल यावे. ओके, गिव्ह मी द अटेंडन्स. रोल नंबर 1.
Present, sir.
2.
Present, sir.
3. 4.
Present, sir.
5.
Present, sir.
6.
Yes, sir.
7. 8. 9. 10. 11.
Yes, sir.
12.
Present, sir.
13.
Present, sir.
14.
Present, sir.
15. 16.
Present, sir.
17. 18.
Yes, sir.
19. 20. 21. 22.
Present, sir.
23.
Yes, sir.
24.
Yes, sir.
25.
Present, sir.
26.
Present, sir.
27. 28.
Yes, sir.
29.
Present, sir.
30.
Present, sir.
31.
Yes, sir.
32. 33.
Present, sir.
34. 35. 36. 37.
Yes, sir.
38.
Present, sir.
39. 40. 41.
Yes, sir.
42. 43.
Yes, sir.
43.
Yes, sir.
44.
Present, sir.
ओके, ऑप्शन नंबर सांगतो. 3, 7, 8, 9, 10, 15, 17, 19, 20, 21, 27, 32, 34, 35, 36, 39, 40. Okay. Okay, stop now.